Hey guys, today we're going to be reviewing how to do the test and try method when factoring to find roots. So this is what you're going to do when you have a trinomial when your a value is not equal to 1. So our first example that we'll get into is going to be 5x squared plus 19x plus 12 equals 0. Now it's been a while since we've had to do this type of factoring. So the first thing that you're going to do is split up the first term. So you have your two sets of parentheses. It's all equal to 0. And the first term is no longer just x squared. In this scenario, it's 5x squared. So you have to think of factors of 5x squared. And the only way you can break down 5x squared is with 5x times x. So that's what's going to start your two sets of parentheses. One has to have 5x and one has to have x. And then, just like how you did before, you're going to list all of the factors of your c term, which in this case is going to be 12. And so you'll start with 1. So you've got 1 and 12. And then you'll move up to 2 and 6, 3 and 4. The next one would be 4, and since we've already used it, we know that we've used all of our factors here. We have them all listed out. Now, because your a value is no longer equal to 1, this is where it gets tricky. So you'll notice that none of these factors add up to 19 right away, and that's because we have to consider that this 5x is going to be multiplying whatever we decide to put in the outer part of the second parenthesis, and the inner terms, so that would be your x, and whatever you decide to put in the first parenthesis, those two things are going to multiply together, and then the result has to add up to 19x. And this is why it's often called the test and try, because you have to test some different things, whether it's on paper or in your head, until you figure out what works. So, if we look at these, 12 and 1 is probably not going to work, because if I put the 12 in the second parenthesis, that would multiply with the 5, and that would give me 60, and that's definitely way too big. I'll never get to 19, so I can't put 12 there. If I move it to the first parenthesis and put the 1 over here, 5x and 1 give me 5x, 12 times x gives me 12x, and 12 plus 5, 12x plus 5x will give me 17x. So that's not going to work either, because I need them to add up to 19x. So it's that kind of thought process that you're going to have to do in your head, again, or on paper to figure it out. But we know that 1 and 12 won't work. So the next one I'm going to try is 2 and 6. So if I decide to put the 6 here, right, 5 times 6 gives me 30, and the 2, I can't use 30 and 2 to get 19, so it's not going to work that direction. If I move the 6 over here and put the 2 here, the 5x and the 2 will multiply to give me 10x, and 6 times x is 6x, but the 10x and the 6x will not add up to 19x either. So that's going to eliminate 2 and 6. So it has to be 3 and 4. I just have to figure out where to put the 3 and the 4, because it does matter. So if I try putting the 4 in the first parenthesis and the 3 in the second, let's see if that works. Now both of these are going to be positive because they have to multiply to a positive 12 and add to a positive term as well. And if we double check our work here, The 5x times 3 is going to give me 15x. The 4 and the x multiplied together will give me 4x, and because those two terms are going to add up to my b value of 19x, then I know it's going to work. So, all that work just to factor. Then, after factoring, remember we're solving still. We're solving for roots. You're then going to, just like you did yesterday, take your factors and set them equal to 0, and then you'll have two x values that you need to solve for. So, when you have this 5x plus 4 equals 0, the first thing you should do in this two-step equation is to subtract 4 from both sides so that you are only left with 5x on one side and negative 4 on the other. And when you get x alone, in the last step you're going to divide both sides by 5, and you can make your answer a decimal or keep it as a fraction. I personally prefer fractions, so one of my x values is going to be x equals negative 4/5. I'll just box that in. And then my other answer is a lot quicker. I just need to subtract 3 from both sides to get x alone here. And I end up with an x value of negative 3. So those are my two answers, negative 3 and negative 4/5, and those are the two x locations where this specific parabola will cross the x-axis. Okay, on to question 2. So with example 2, we have 2x squared plus 3x minus 9 equals 0. First thing we're going to do is we're going to have two sets of empty parentheses set equal to 0, and we're going to break up the a term. So that a term is 2, and then it has x squared attached to it, and the only way that you can break up 2x squared is by 2x and x. Then you're going to list all of your factors of c, which in this case is negative 9. So you're going to have negative 1 and positive 9, negative 3 and positive 3, and we've hit them all. Now we also have to remember that whatever we decide to put in our parentheses, the placement matters. The 2x is going to multiply whatever we decide to put in the second parenthesis, because our outer terms are going to multiply with one another. And whatever we decide to put in the first parenthesis is going to multiply with the x, because our inner terms are going to multiply with one another. So, if we figure this out, they need to eventually add up to 3x. So if I try putting a 3 in both of the parentheses, one has to be positive and one has to be negative. Now, because I want them to add to a positive 3, I'm going to make the first 3 negative, second 3 positive, because the outer terms will multiply to give me 6x, the inner terms will multiply to give me negative 3x, and when I combine these like terms, I end up with 3x, which proves that this works. So, after we have factored correctly, we are then going to take each of our factors and set them equal to 0, so that we can then turn around and solve each of these equations. So the first equation, 2x minus 3 equals 0, we are going to add 3 to both sides to get that x term alone. So you're left with 2x equals 3. Then you're going to divide both sides by 2, and you're going to end up with the fraction 3/2, or if you prefer decimals, you can keep it as the decimal answer. Up to you. The second equation, if we get x alone, we are going to subtract 3 from both sides, and we're going to end up with an x answer of x equals -3. And we're only going to do one more example today. So example 3 is going to read 4x squared minus 35x plus 49 equals 0. And the tricky thing about this particular example is that there's two possibilities that we have to consider when solving this with factoring, because that 4x squared can be broken up two ways. So it could be the typical 4x and x, but then you can also break it up 2x and 2x, and only one of these is going to work. So if you want to pause the video now, try this on your own, and then when you're ready, hit resume to see the correct work. Go ahead and do that. Okay, so over to the side, I'm going to list the factors of 49. So we're going to have 1 and 49 and 7 and 7. Now, because these have to multiply to a positive but add to a negative, I know that both of these factors have to be negative. Now, 49 and 1 being a possibility is going to make it hard for me to get to 35, even when one of those terms is multiplied with either the 4 or both are multiplied by the 2. So, I know that's not going to work. Using -7 and -7, we can try it in the first one. If you multiply the outer terms together, you're going to end up with -28x, and then -7 times x is -7x, and when we combine these like terms, we're going to get -35x. So, I know that it has to be the 4x and the x one that will work, so I'm going to erase the other option. Now that I have the correct factors, I'm going to set each factor equal to 0. So I have 4x minus 7 equals 0, or the other option is x minus 7 equals 0. And then I'm going to solve for x. So in the first equation, I have to add 7 to both sides to get x alone, leaving me with 4x equals 7. And then I'm going to divide both sides by 4, and I'm going to keep my final answer as the fraction 7/4. So there's one answer. The other is a simple one-step equation where I just have to add 7 to both sides, and I will end up with my x answer of +7. So there you have it. Your two final answers are x equals 7/4 or x equals 7. And that is going to conclude our notes for today.